we're going to flip-flop the days. So even though P is the last step, or preparation is the last step in the F-step process, we're going to talk about preparation a day, so you kind of have that in your head going into tomorrow. All right, and then tomorrow we're going to talk about execution, so it's fresh in your mind when you're setting up to create your own dish. Okay? So P is for preparation. And so if you're a professional cook, this is what most of your day is made up of doing, is prep work, right? You're getting ready for battle. And this will immediately not only make you a better cook, understanding these concepts, but also understanding the mindset of, I need to get prepared for battle, even if you're just doing a simple dinner. Because it's very easy to say, okay, well, I'm going to pan roast a chicken breast, I'm going to make some veggies, and you throw your chicken breast in the pan, and you start cutting up your veggies, and like, oh no, my chicken breast is starting to brown too much, and now you got to put it in the oven, and then you got to run over and finish cutting your veggies, and it really kind of screws with your timing. It also messes with your ability to pay attention to the task at hand. So it's almost a comfort blanket when you have all of your things prepared. But it's not just vegetable prep, it's also prepping the various components of your dish. So, sauce making kind of falls into prep a little bit. Blanching falls into prep a little bit. Brining and marinating falls into prep for sure, because those are things that you have to do, sometimes a couple hours before, up to a couple of days in advance. Okay, so we already talked about blanching green vegetables, which is a major prep technique that every cook needs to understand. We talked about that in our sauce section when we were talking about making a green puree. Does everyone feel like they're comfortable with the idea of blanching green vegetables and why we do it? Yes. Okay, does anyone have any questions on that concept? And is everyone comfortable with why we start root vegetables when we blanch and why we start them in cold water and bring them to a simmer? Right, complex starches, they just cook more evenly. And then because they don't have chlorophyll in them, and because they have a sturdier structure, they won't overcook as quickly, and they're not going to turn color on you, so it's not as important to shock in ice water. You can. It's not going to make them any worse or any better. But generally speaking, we just pour out the hot water, run some cold water through it, just because it's easier, and you don't have to go. And especially at home, I have an ice maker in my home fridge. It's like a little box, but I can kill that easily just by blanching some green beans. If I'm going to serve root vegetables and green beans together, it's nice to know that you don't have to shock in that water.
I have a question for purple carrots and purple potatoes. Mm-hmm. Why do they come out gray? They don't have that vibrancy. Like if you peel a purple mm-hmm. potato and you boil it, doesn't it tend to turn like a gray color? Oh, maybe it's my water.
Yeah, I'm not sure because we had those purple baby potatoes yesterday that we had blanched. We served with our beef bourguignon. And they're not as vibrant as when you first cut into them. But I've never had my purple potatoes or carrots turn gray. So it could be an acid alkaline thing. I don't know. Maybe because if you have hard water, maybe there's more alkalinity, and there's something, and alkalinity breaks down cellular structure of all vegetables. So maybe somehow it's releasing the color into the water. But I'm not sure. I haven't had that issue, so I haven't had to troubleshoot it yet. But that might be something to look into. And you can get pH testers online for fairly inexpensive. I mean, you can get the strips, but you can also get like digital meters, which we have because sometimes we need to know the precise pH of a brine or a marinade or something. So that might be a fun little rabbit hole to travel down. But off the top of my head, if that's happening too, that would be my first guess, because you don't really have many variables. You have the produce and you have the water. So, yes, sir.
So, if you wanted to roast your root vegetable, do you still blanch it? I mean, like a beet or...
Mm-hmm. Excuse me. It depends. So beets, I just slow roast, because you also have, with beets, you lose, when you boil it, you're going to lose some flavor. You can always steam it. Let's actually talk about the other two preparations of root vegetables. So if we're going to be preparing root veg, we have the basic blanching, and this is why I list this in your F-step worksheet, under the prep section is because it's just to kind of get your mindset to be like, hey, I could do a crazy technique with root vegetables that may not be listed, but the basic applications are you're either going to blanch them, you're going to slow roast them, or you're going to glaze them. All right. So we understand the blanching and the cold water start. You're basically just going to bring that to a simmer and then check with your knife until it's tender, and you're going to cool them off. Pretty simple. For roasting, so we talked yesterday about slow roasting meats, and then you have that temperature gradient, and so you have a lower temperature so it cooks more evenly all the way through. So with things like potatoes or beets, you can roast them at a lower temperature and have a more even doneness. Now beets are kind of the exception to the rule, and that's why I like to wrap them individually in tin foil, because as they roast, they release steam. So I roast them in a really hot oven, like 450, 500 degrees. But the fact that I have them in tin foil releases steam. That steam envelops the beet, and then so it's a more gentle cooking method. Okay, so you could literally take a beet and drop into a steamer and almost have the same effect of our style of roasting. But over time, the steams, as the beet dries out a little bit on the exterior, and we rubbed it with oil, it'll have some roasted notes as well. Okay, so that's how I approach beets. But you can roast, and root vegetables are definitely more forgiving than a meat that you'd want to slow roast. So it's basically just a time temperature of accomplishing your end goal. Which is enough time to cook all the way through and at the proper temperature to get your desired doneness. So with like potatoes, the potatoes that we made on the first day, if you cut potatoes in half and you toss them in canola oil, or whatever oil you want, you place them cut side down, and you pop them straight into an oven, like a 325, 350, they will slow roast, and you're you're trying to get that perfect meat in the middle where they finish roasting and they have that perfect texture while the cut side browns. But to me, it's a lot less forgiving than first getting the perfect texture by blanching and then just finishing them in high heat. So you're separating the two ideas, and you're saying, okay, well, I'm going to get my texture done first, then I'm going to cool them, and I'm just going to roast them really, really, really hot. Or you can, and at that point too, you can even pan fry them. You just stick them cut side down in a pan, fry them until they're crispy. If you're worried that they didn't sit in the pan long enough, so they might not be hot all the way through, then you can even add some more flavor by hitting with a little bit of wine or a little bit of stock, and then covering with a lid, and then you develop some steam. Okay, so just separating it out is a little more forgiving. But you could also just slow roast any root vegetable. Okay? And that's pretty much it. And it's just playing with your oven setting. It's your temperature dial. Everyone's oven is different. And the reason why there's a lot of differentiations in ovens is not only are some ovens are less or more accurate than others, but the way your oven heats itself is an on and off cycle. So if I set my oven at 350 degrees Fahrenheit, what it's going to do is it's going to turn on and it's going to heat itself to 400. And then when it hits 400, it's going to turn itself off and it's going to kick back on at around 300 or 325. And depending upon how your oven is constructed, some ovens have a 25 degree differential, some ovens have, a 50 degree differential. So it depends on the oven and how it's set up. So every time you open your oven as well, you can have a 15 to 25 degree loss. So if your oven swings up like this and then drops back down and you open your oven door around here, then all of a sudden it drops below 300 and it takes longer for it to come back up. So it makes so cooking in an oven isn't an exact science. It's more of an intuitive experience where you get used to your own oven and you're like, well, this recipe says roast my potatoes for an hour at 375, but I really found for my oven, I need to roast them at 325 with my convection fan on. And it just might happen that your oven is much more efficient than the oven that they use to test that recipe with. The third way to treat root vegetables is to glaze. And basically what you're doing with that is you're simmering vegetables in liquid, most of the time just water, and you add just and some white wine. So classically speaking, you'll add a little bit of white wine. It's always considered bad form to mix other ingredients with wine until the wine has been treated with some heat to reduce. You want to cook off some of the alcohol and cook off some of the harsh flavors of that raw wine. So you'd add your wine first with a little tiny pinch of sugar, tiny pinch of salt, and then you place your vegetables in it. You start the simmering process, you simmer it down, and then once your wine has reduced by about half, you cover with a liquid. You can usually just do water. And then you throw in some butter right on top, and then you raise the temperature to high, and you rip it down, and again, it's a timing thing, just like roasting, where you want to, by the time your stock reduces or by the time your liquid reduces, your vegetables should be cooked through. Now, it is a little more forgiving because if you're saying, okay, well, I'm looking at my vegetables and the water level is getting low and my glaze is starting to form, but my vegetables are still a little bit too al dente for me, then I'm going to just add in another ounce or two of water and let it go and reduce a little bit longer. You can throw on a lid to kind of keep some of that steam in there from evaporating off, and steam, and then take the lid off and let it reduce further.
So last night, were the root vegetables blanched before you guys?
They were.
Okay, so they still need a little bit of pre-cooking to...
Not really. At that point, we're heating them through, which I'm going to talk about right now. So that's the traditional method, which is very, very finicky. So the all minute method that we use for dinner service, that I like to use at home, is again, we're going to control the texture of our root veg by blanching. And this allows you to do that beautiful mixture of glazed vegetables that we did last night, because a fingerling potato and a marble potato and a Thumbelina carrot and a baby parsnip are all going to they're all going to be done at different times when you glaze them or when you blanch them. So what we did last night is we prepped them all separately, right? We placed them all into cold water because they were all root vegetables, brought them up to a simmer, and then when they had the appropriate texture, we just placed them under cold running water to cool them down, and then we were ready to go. So then what we do is we add the white wine. So white wine.
Are you doing that on a high burner as well, or medium?
So medium on the white wine, you can. So again, this is just, when reducing this white wine, doing it on a lower temperature, you're going to have less flavor loss. So it's not one of those things where you have to reduce on low, right? But just be conscious of the fact that you're not going to have as much flavor from white or red wine if you reduce it rapidly. So when I get an order for our beef bourguignon at Stella, I just throw a pan on and put it on number 5, which is like medium heat, and add the white wine in, throw my vegetables in with the sugar and the salt, and I let it just slowly reduce until it's just enough to coat the bottom of the pan. At that point, we add chicken stock, and this is why you don't always want to do a roasted stock. So we do a white stock where we take the bones and we blanch them first. We start them in cold water, bring them to a boil, pour that off, and then cover with water again, bring to a simmer, and add unroasted mirepoix and aromatics. So we have a much lighter stock that's going to add some flavor to our vegetables, but not overpower it, but it's also not going to destroy our color. Think for a second, if I took the demi-glace and I threw it in with my vegetables, it would definitely glaze it. But the reason why we separated it out from our beef bourguignon last night is because we wanted to show off our beautiful fall baby vegetables. So we plated our bourguignon separately and then put the glazed vegetables on top. Also, too, it allowed us to, again, separate out the different cooking times. So my vegetables might be ready, but my beef bourguignon isn't. So this allows me to make sure that my beef bourguignon is ready and at its best quality, and my vegetables are ready and at their best quality, and I combine the two on the final plate up. So the small amount, and this was a really light stock. This was literally it wasn't reduced, it wasn't reinforced, it was just your standard chicken stock. But when you think about taking about 4 ounces of that stock, which is what we use to cover our vegetables in our 6-inch saute pan, by the time that stock reduces down to literally nothing, you're reducing it down to where there's no more moisture in the pan, the stock has been reduced by much more than a quarter. A quarter of its original volume. So what we do is we basically say, hey, we're going to break the rule of understanding that you should never boil a stock because it incorporates fat and it makes an emulsion. What happens when you emulsify fat into a liquid? Well, it becomes thicker, right? So that's how we form our glaze. So the sugar acts as a bit of a stabilizer. The gelatin in our stock acts as a bit of a stabilizer. So once the white wine is reduced fully, I just basically cover the vegetables with stock. And because the vegetables are already cooked perfectly, by the time it comes to a simmer and comes all the way down, I know that my vegetables are going to be heated all the way through. So I just throw a couple of pats of butter right on top, turn the burner up to high, and I just rip it down as rapidly as I can. And you come by, once it gets about halfway down, you start paying closer attention, give the pan a little shake, give it a flip, and then at the end, when you have those rapid bubbles forming because your stock is thicker and it's almost completely gone and it's turned into a glaze, you kind of start looking at it and flipping it around, and then when your pan looks pretty much dry, you turn off the flame. And you're still going to have a glaze in the pan, and you can take it past the point of no return where you basically break the butter out of the sauce because you have no moisture left, because without any moisture in the pan, you're just going to have fat, right? You no longer have the ability to have an emulsification. So toss, or stir, whatever you're comfortable with. And what's great about this, especially in the wintertime, is, well, number one, the root vegetables are seasonal and they're at their peak. But number two, you have that reduced glaze that coats the vegetables, and it's a sugar glaze. Because you're using some of the sugar that you did, just a small, very, very small pinch, but because it's formed into a thick glaze, it can retain heat a lot better than a thin broth. So you stick it on the back of your stove and you put a lid over the top so the heat doesn't escape, but no heat underneath the pan. And then you can do your final preparations where you pop your hot plate in the oven. You can focus on your seared steak or carving your chicken or whatever you're serving with it. And then when you're ready for your protein to be served, your vegetables are already done and they go on the plate. It's also too why I like to serve saucy dishes during the winter time, is because not only are they more hearty and people tend to crave them, but they hold heat much better. When they come in out of 20-degree weather and it's in the middle of a snowstorm, they want their food to be piping hot. And so the way that you do that for them is by giving them a substantial sauce like the beef bourguignon glaze that can really hold some temperature. And you saw that last night, even though we plated it up and we didn't have any heat lamps or any heating elements, that beef bourguignon held its temperature for a while. And that's pretty important at home, because at home, you got to work with the space that you're given. So maybe you can't plate everything at once. Maybe you don't have the space to lay down 12 plates or however many platters you might need, or maybe you forgot to set the table or something. So when you call everyone to dinner, you have some time, you have some wiggle room for people to sit down and eat a hot meal. Yes?
Brown sugar?
You could use brown sugar. The sugar is mainly there because just a small amount of that sugar is going to help you form your glaze, but it's also there to balance the acidity in the white wine, because once that white wine is reduced almost all the way, it's going to be fairly acidic. So you're usually not going to have to finish with an acid, but you can taste, because it depends on the white wine that you're using. We always use, so for our all-purpose cooking wines, we use a dry Chablis, which is a French Chardonnay, and then we use dry Burgundy. And again, they're specifically chosen for not being any too one-dimensional in any direction. But a dry Chablis is always going to have some acidic notes to it, which is nice. So when you reduce it down, you always want to taste your vegetables, taste your food. That's number one thing of everything you do in cooking, is at the very end you have to taste. You have to taste everything. And then, we've been drilling in your head all week. Fat, sugar, salt, acid, and you taste it and you say to yourself, okay, well, it needs some salt. You know, it's a little flat, it's a little bland, or hey, my glaze got a little too sweet. Maybe the vegetables themselves were at their peak and a little bit sweeter, or maybe you didn't have such a dry white wine. And then you add some acid, you add some lemon juice, some vinegar, whatever you may need. Okay?
So how much white wine and sugar? You were saying a pinch of sugar and...
Yep, just literally like a one finger pinch of sugar. Yep, and white wine just enough to cover the bottom of your saute pan by about 1/8 of an inch at the most. So not a whole lot. Yes.
So do you utilize sous vide in cooking your vegetables in the restaurant? And so what application do you use that for?
So you can blanch sous vide, which is kind of tricky. And I don't really recommend it until you get really comfortable with sous vide. But you could also cook your vegetables sous vide. And there's a universal temperature at which vegetable starches break down, which is 185 degrees Fahrenheit. And then depending upon the size of your vegetables, you're going to go anywhere from 20 to 60 minutes. And this will cook your vegetables thoroughly all the way through. Now, with that said, we rarely do this at Stella because we only have 2 circulators that are our workhorses for other stuff that I think are more important. But this could also lead to some cool implications for execution. So if you have a couple of days ahead of time, because we're here every day just piling stuff into our circulators, like they're always going. But if you're at home, you could actually take your vegetables. If you want to get really fancy, you could vacuum pack them all separately. I don't think it's necessary unless you have something like a purple carrot that's going to bleed color. But you pack them with some butter, a little bit of white wine that you've already reduced so you don't have that harshness, a little pinch of sugar, a little pinch of salt, and then maybe a couple ounces of stock, which is optional. But you could also, if you're just using an Edge vacuum sealer, you could just freeze your stock and throw them in as ice cubes. Or you could do the Ziploc baggie trick that I demonstrated the other day. Okay? Drop that in, cook it for about 30 to, for the root vegetables, my best guess would be about 30 to 45 minutes. Then they're tender and they're cooked all the way through. And because it takes such a high temperature to break down those starches, then say you're serving a filet mignon, okay? You have your bath set at 55 degrees Celsius, and your filet is cooking, nice. Okay, I'm about 30 minutes out from serving, so I'm just going to take my vegetables, I'm going to clip them with using a binder clip to the side of my immersion circulator. I'm going to have my 2 saute pans, one for my filet, one for my vegetables. Okay, it's getting close to me pulling my filet and searing it. You're going to turn up the heat on one saute pan, grab your bag of vegetables, open it up, pour it in, let that reduce for your glaze to form, grab your filet, pull it out, cut, sear, and then they're both ready and you just plate. And because the vegetables are already warm all the way through, you can pre-reduce your chicken stock to like a demi-stage. All right, so that way when it hits the pan, you're basically reducing it for 60 seconds. And so those are one of the things that make immersion circulators really cool when you start getting used to using them. Is not just the fact of their consistency in the product they yield, but the execution, which is why I think they're going to be massively popular for the home cook, because it makes it a lot easier to pull off dishes that you couldn't do before because there's too many working components. Whereas now you're just focusing on finishing, right? Sear, reduce, done. Yeah.
Is that 185 just for root vegetables?
I'm sorry?
Is it just for the root vegetables? The
185, yes.
Just for root vegetables, so something else would be, other vegetables would be a different temperature?
So all vegetables that have structure, so mainly root vegetables, radishes. So you can do asparagus, which is a green vegetable. You would still, because they all share the same, pretty much the same makeup, you would still actually cook it at 185, but you wouldn't cook it for quite as long, and it's more finicky, okay? Because if your bath drops too much when you drop the asparagus in, then the chlorophyll in the asparagus spends time in that window where the enzyme hyperactivates and turns it gray. So it can be done. It's done in a lot of high-end restaurants because at those restaurants, consistency is everything. And they're also large. So here I work shoulder to shoulder with my cooks every single day. You know, you go to a place like the French Laundry, they have like 50 cooks. You know, they have team leaders for every like 5 to 10 cooks. So it just makes it a lot easier to give them a recipe book. Like your asparagus, you drop it in a 185 bath for 10 minutes and you shock immediately. You know, so it works, but to me it's also just faster and simpler to just understand how you like your asparagus and blanch it the traditional method, especially at home. So there's a lot of cool things that you would do with an immersion circulator at home that will make your food great. Blanching asparagus or green beans, I don't think is one of them. Personally, if you disagree with me and you play around with it and you say, yeah, this is like the best way I've ever done green beans, you know, then those are the kind of decisions that I want you to make. You know, I want you to not take my word as gospel. I want you to take it as a starting point to make your own conscious decisions of how you like to cook things. Okay. Any more questions on les root vegetables and glazing? So do you feel fairly comfortable with the concept of glazing baby root vegetables? Right? It's really, really simple, and it's a great way to serve them. And people just flip. Now, by the way, you can use this to pick up any vegetable. So the green beans underneath our filet set, we actually glaze those as well. So they're already blanched, already the texture that we want. So but because green beans heat through faster, and then we can start cooking them more than we'd like them to, and they can break down the color, instead of throwing them in and covering with stock and reducing the stock down, we actually make the glaze separately and start reducing it down. And then once the glaze gets to the point where maybe we're 30 to 45 seconds out, we take our cold green beans that have already been blanched, throw them in, toss them in the glaze for about 30 to 45 seconds, or enough to heat them through, and then we serve. And so it allows us to heat them, glaze them, which just adds more flavor. It also will keep them warmer on the plate, and then serve them. All right, brining. It's where we answer a lot of questions. It's also where I need a lot of colorful pens. Has anyone brined before they came to boot camp? Almost everyone, right? Has anyone not brined before boot camp? You have never brined. Wow.
Going to the corner.
I use salt and water for boiling pasta and stuff, but I've never brined. Never the protein.
Okay. Did you see the difference in the chicken breast that we served for lunch on Monday?
That was nice.
Yeah, and you notice when you cut into it, not only is it more moist, but also the proteins are more condensed, more even. Okay, and so it allows, especially with lean cuts of meat, brining is really, really important. We brine a lot of things here, either whether it's a dry brine, which is salt, or a wet brine with moisture. And so understanding how brine works will not only make you a super cool guy or girl, but it'll also allow you to really play with the concept and make it your own, which is important. Because again, once you understand, when I finally realized how a brine actually works, instead of just saying, oh, it adds moisture to a dish, then I was able to develop brine recipes specifically based on that knowledge that made my food even better. Okay, so first, let's talk about osmosis, because this has an important implication in brining in general. So in osmosis, basic concept is you have a semi-impermeable membrane, meaning that some molecules can fit through it, but some can't. And on one side of that membrane, you have a higher concentration of water than the other. Oops, I should actually make these guys smaller. Let's pretend these guys are this size, okay? And what makes osmosis actually happen is the fact that you have on one side of the membrane a solute or a dissolved solid, which is what's making the concentration of water on this side lower than the concentration of water on this side, okay? And they say, over time, if given enough time, the water will equilibrate across the membrane by moving into here. And why does that happen? Well, what happens is it's all random, it's all math, really, is the fact that these solutes, these molecules, are too large to fit through this membrane. So again, temperature is just a measurement of molecular movement, right? See how all this stuff kind of comes full circle? So even cold water is moving. Those molecules are moving. They're just not moving as rapidly as like a boiling water, but you take the temperature, it's 70 degrees Fahrenheit or whatever, those water molecules are in constant motion. They're bouncing around. So these guys are all just moving in random directions. But randomly, when this water molecule is coming here, okay, it can bounce off this solute and go there. It can bounce off this and go there, depending upon its approach path. But as these solute molecules, which are also moving, get randomly closer to this opening, right, the likelihood of these guys making it through on this side is lower. They're going to bounce off here. This guy's going to come at this approach path and bounce back down here. Okay, so you're going to have more water move to the side with the solute than the other way around. And that's osmosis. Now, why do we even care about this, right? Well, because forever, brining has been related to osmosis. That's how people have described how brining works. They say, oh, why do my protein, like if I drop my chicken breast into a brine, well, why is it that it soaks up more moisture? And people think back to their 6th grade, biology lesson or chemistry lesson. They say, oh, well, I remember my teacher talking about osmosis and the movement of water into a membrane. And so water's moving in, so it must be osmosis, right? And because it's not osmosis, it opens up a new understanding for us. So you need to be able to first explain to people why it's not osmosis, if they want to argue with you about it, and then explain to them that, no, it's not really osmosis. What's happening in brining is diffusion. So you have a container of anything. Say these are gas molecules. And what are the molecules doing? Well, they're moving around, okay? And they're all concentrated in this lower left-hand corner. Given enough time, as these guys move around, maybe this guy tries to move down here, but it's jammed, so he's going to knock into another molecule and move back up here. This guy goes down here and it's jammed, so he goes out over here. Over time, they'll form an equilibrium, statistically speaking. More or less, they're going to form an equilibrium. They're going to spread out evenly. So what happens when you have your brine container, so let's go through the process of brining a chicken breast. So I have my container. Use one of those square plastic Hambro containers that we use in the restaurant all the time. And here I have my water line. And I'm going to drop sodium chloride in my water, which is table salt. Okay? So when I drop it in, as soon as the sodium chloride hits my water, it's technically no longer sodium chloride as we know it. It now separates into separate sodium ions and chloride ions. Now this has important implications because we take our chicken breast that we drop into the water, and these guys split into separate sodium ions and chloride ions. And now, because there's no sodium or chloride in our chicken breast, the sodium and chloride ions need to try and equilibrate. So they start attaching themselves, first the outside of the chicken breast, because again the ions are just slowly moving around in this water. And this is the same exact concept as heat diffusion. We were talking about temperature gradients, right? So you put a fillet in the oven when you're pan roasting to finish at 500 degrees, and that heat diffusion diffuses inward, but the only difference is heat diffuses much more rapidly than a brine will diffuse, or the sodium and chloride ions in a brine will actually diffuse into the meat. So it takes longer, but it's the exact same concept. Okay, so these guys start to attach and then start to move inward and diffuse. Now, the chloride ions themselves, this is going to be our zoom of muscle fibers. Okay? So let's zoom out. So the chloride ions are negatively charged. So we'll put a little negative here. And they attach themselves to muscle fibers. And because you have a negative charge, it'll actually spread these muscle fibers apart ever so slightly. And what that does is it allows room for more water to be taken in to those gaps in the meat. So there's already natural gaps in a chicken breast. So you can take a chicken breast, you can drop it into water without any salt, right? And you pull it out and you weigh it, and it's going to have gained about 4 to 5% in water weight, just because that water is going into the chicken breast. Now, what else happens though, and it's also why you get a different texture with a brine chicken breast, is these chloride ions partially dissolve the protein fibers, making them slightly weaker, which gives them a softer texture, but also allowing them to bind more readily to water. So as this water comes up between the muscle fibers, they're actually able to bind to the water and hold on to the water during the cooking process. Now this is important because if you take that same piece of meat, you throw it in water without any salt, and you pull it out, it's going to release all that moisture during the cooking process, and you're not going to have done really anything. Okay? But also, too, sodium chloride isn't the only salt out there. So you have sodium hexametaphosphate, which has more negatively charged chloride ions than regular sodium chloride. You also have calcium chloride, which you used last night to make your spherification. Calcium chloride in high concentrations is bitter, but at about 0.3%, it'll add enough negatively charged ions to your brine to even spread the muscle fibers further and allow more water uptake. So with this knowledge of, well, a brine doesn't work through osmosis, it works through diffusion, and because the negatively charged ions are attaching to the muscle fibers, partially dissolving them and spreading them apart, I can now play with other forms of salt to increase my water uptake, and to, specifically with charcuterie and curing things where it's important to have a certain amount of water content in them. Also, too, what this helps to solve is the myth of pre-salting meats. How many people have heard don't salt your meat before cooking because it dries it out? Right? And it seems logical. You salt a steak, right? And actually in this point, the salt is drawing water out of the meat, and you can see it on the surface of the steak from it being salted. But it's a very minuscule amount. But anecdotally, just by looking at it, you can say, oh yeah, I salted it and it's drawing moisture out. And it happens to a certain extent. But what happens is if you let it rest longer than 10 minutes or so, First of all, if you don't let it rest longer than 10 minutes, the moisture loss is going to be negligible. You're basically just seasoning the meat and then searing it. So you're not really going to have any moisture loss. But you're basically forming a concentrated brine over time. As the meat juices come up, they dissolve the salt, and the salt diffuses back into the muscle fibers. And that's dry brining. You pre-salt something and you let it sit overnight for a couple of days, but even just an hour or two helps. And the reason why that helps is because even though you're not adding more water content for the meat proteins to bind to, the meat proteins are still affected by the salt, and they are tenderized, and they are allowed to hold on to the moisture that's already contained within the meat. So when you pre-salt a steak or a piece of meat, you're changing those muscle fibers to where they can maintain the moisture that they already have, and will come out actually moister than if you salt the meat after cooking. Yes?
Could that be used for tenderizing, say, carrots that are a little bit tougher, or meats more with vegetables? Can that be used to tenderize, if you will?
No, because salt doesn't affect the starches in vegetables like it affects the proteins in a meat. But that's also why you see a lot of, look at dry rubs used in barbecue competitions. They're mostly salt, and then they add other seasonings for the flavor of the dry rub. But what makes it important is they're basically pre-salting these large pieces of meat and allowing the salt to diffuse in. Now, this is also because brining happens through diffusion. It's also why it's important to first rinse your meat and then allow it to rest before cooking. Ideally, you can take a piece of chicken out of the brine and rinse it to get the extra salinity off and then cook it. And it's going to be better if you hadn't brined it at all. But the resting stage, so again, because it works through diffusion, at any point when you pull your brine or you pull your chicken breast from that brine, there's going to be more of a concentration of sodium and chloride ions on the surface than on the interior, okay, because they haven't been able to fully diffuse yet. So to counterbalance that, you rinse these off. You rinse off the exterior. And then you let it rest. And as you let it rest, the sodium and chloride ions within the meat are going to continue to diffuse until they more or less equilibrate and you have more of an even salt gradient throughout your meat. Okay? Now this, in your book, the concept that we're talking about right now is gradient brining. Meaning that we have a higher salt content in our brine than we want our finished product to have. Okay? Now, when a meat starts to continually uptake salt and reaches about 6% mark, it is now going to start to cure. So there is a point of no return. So at about 1.5 salt percent, it's going to be overly salted. You're going to taste it, it's too salty. So you're still shooting for about a 1% salt content in your finished product, which is our sweet spot. But the salt will continue to allow the meat to maintain moisture or uptake moisture until it hits the 6% mark, at which point it starts constricting the muscle fibers and pushing out moisture, which is exactly what happens when we cure meats, right? We salt a ham, let the ham sit for a month in salt sometimes, and then we hang it, and because it contains so much salt, it starts to extract moisture over time. Okay? So the other method of brining, which takes a lot longer, is equilibrium brining. So this is basically the sous vide of brining, in the sense that when we cook a roast in a traditional oven, we're using a temperature gradient to bring that to our final finished temperature. When we cook lamb chops in an immersion circulator, we set it at what we want our finished temperature to be and let that lamb chop slowly come up to temperature. So in this sense, if we're saying, hey, I want to have a final finished salinity in my chicken breast of 1%, then I'm going to take the total weight of my chicken breast, I'm going to match that weight with the same weight of water. I'm going to take the total weight, so say I have 1,000 grams. I have 1,000 grams of chicken breast, so I'm going to do 1,000 grams of water. So my total weight is 2,000 grams. I want to have a finished salinity of 1% inside my chicken breast, which contains no salt at this point. So I'm going to times that or multiply that by 0.02, which is going to give me 2%. Okay? So it's going to give me 40 grams. Then what you do, what gets complicated, is of salt. Mm-hmm. I want 1% in the chicken.
But you have 2,000 grams.
Yeah, so.
Because you got the chicken and the water.
So I have 1,000 grams of water. I want 1%, because this will form an equilibrium over time, but I only have 1,000 grams of water, so I'm going to start with a 2% brine in the water, okay? And you start with an equal amount of chicken because it makes it easier to take salinity readings, which is the only way that I actually do this accurately. So you dissolve your 40 grams of salt into your water, you cover your chicken breast with it, and then over the course of 3 to 5 days, it will equilibrate. So now you'll have 1% in here and 1% out there. The only way to truly be sure, though, is with a salinity meter, which costs like $200, and it's not really worth your money, to be honest with you. But it's just important to understand this concept because that's how some chefs will actually do it. But it takes a long time. It's a pain. And we don't use equilibrium brining because we feel very comfortable with our gradient brine. But that's just something that I want to make you aware of because it might be something that you want to actually play with because it is much more precise and accurate, but it takes a lot of time and a lot of effort to do it. Well, it takes a lot more time.
Time to sit, you mean?
Yes, so it takes a lot more time for this to equilibrate because there's less of a gradient, right? So the more salt you have in here, the faster your end product is going to brine. So if you have a 10% brine or a 15% brine instead of 5%, the salt is going to attach to your meat and diffuse into your meat faster than if you had a 1% or a 2%. Okay?
So what equation will we use then, going back to gradient brining?
So the equation, okay. So the equation that you use, so it just so happens.
So theoretically, if you were equilibrium brining, you couldn't oversalt the food because it's
Correct.
never going to be more in the chicken than it is in the water.
Yep.
So that's kind of what.
Exactly. Same way that you're never going to overcook a chicken breast if you sous vide it.
So gradient brining it, you're going to increase the salinity, but then if you have it sitting in there too long, you could oversalt your meat.
Absolutely.
Okay.
So
Yeah.
how long does it have to sit in the equilibrium?
So it depends.
Until it equilibrates.
Yeah. That's where you use the meter. So there's no set time.
Average, like what would you say? I mean, what's...
What are you brining?
Okay, let's say Thanksgiving turkey.
Turkey, you're looking at maybe a week.
Oh my gosh.
Yeah, exactly.
Okay.
Yeah, so the larger it is, the longer it's going to take to form an equilibrium.
Okay.
And also the temperature, right?
Huh?
The temperature would affect it too, right?
Yes, it will diffuse faster at room temperature, but exactly. So you're so you. It's not enough. It's not enough salt. Yeah.
The thing, what do you do with this turkey while it's brining?
Exactly.
Yes. And everything
Inject it.
else.
Yeah. Well, that's also why I recommend breaking down your turkey, and dealing with it separately. And we can. It looks kind of like we're a little ahead of schedule today. So if you want to, we can do like a quick crash course on Thanksgiving. You can ask your Thanksgiving questions, and we can talk about it.
Yeah.
Okay.
That's our first test.
So.
That's what I was going to do for my
Cool. We don't have any turkey though. So you can do chicken. So to answer your question about gradient brining, which is what I recommend everyone use because that's what I'm comfortable with. So over the years, I just developed an affinity with a 5% brine solution, right? So that's what you have in your books as far as your time and temperature, I mean, not time and temperature, your time charts for brining. And again, this is just my personal preference of how I like my brine foods. This is what I brine them for a certain amount of time, I rinse them, I cook them. If you're sensitive to salt, you might think that they're a little over-salted, but it's what we use in the restaurant and they are universally accepted. But again, there's no hard, fast rules. There's just information that is a starting point for you and you can make your decision based upon that.
Okay, and you know, there's so many brine recipes out there, but the most critical factor is the salt. And after
Yes.
that, like when people have fruit juices and then, you know, peppercorns, all that kind of stuff, that's all just flavor.
Yep.
'Cause
Yeah, so
the sugar molecule is not doing this, it's the sodium and the chloride ions. That are,
absolutely. So the sugar is there to balance the harshness of the salt. Okay, because sometimes salt has like that metallic, almost burn flavor. So you add a little bit of sugar, and sugar and salt balance one another. So that's the pure purpose for sugar to be in there. And also, too, a little bit of sugar, because so our basic brine formula is 5% salt and 3% sugar, by weight, of course. And even with longer brine times, again, you need to have more parts per million of sugar than any other flavor out there to actually have it be perceptible to your palate. So it will act as a seasoning in the sense that it adds a slight hint of sweetness, except you can't really pick up on it. It's mainly just balancing the salt. But also, too, it's going to help you caramelize easier, or more directly, it's going to help you create the Maillard reaction more easily. So if you take a brine chicken breast and then you pan roast it next to an unbrined chicken breast, you're going to have a darker, richer color on the brine chicken breast that contain a little bit of sugar. Yes, sir.
So it's by weight of both the water and the protein?
Just the water.
Just the water.
Yeah, so again, we're using the baker's percentage of scale. And so this is what makes it easy, though. This is what kind of shows you the scalability of this process or this formula, is I have chicken breasts. I throw them in a container, and like, look at it, it's going to take me about 1,000 grams to cover these chicken breasts. And that's all you have to do with the gradient brine, is you have to cover whatever you're brining. And once they're submerged, the brine is going to work. So you say, okay, well, it's going to take 1,000 grams to fully cover. Well, then I know that I want to have 5% salt and 3% sugar, so I'm just going to make my simple multiplications. I'm going to multiply 1,000 grams by 0.03, multiply 1,000 grams by 0.05, dissolve that into my water, and be done with it. So the extra flavors that you add, a lot of flavor molecules and aroma molecules, they're actually too large to penetrate inwards into the protein that you're cooking. What happens, though, is there's certain base aromas or base flavors that you can actually dissolve into the water that are water soluble. But remember, a lot of our flavor molecules that contribute to aroma aren't water soluble, they're only fat soluble. So you're not going to be able to infuse them into your water. But what you want to do is, if you're going to use flavorings in your water, and this is just a suggestion, because sometimes even at home when I'm in a rush, I'll just take some toasted peppercorns, I'll take some bay leaves, I'll take some thyme, I'll throw it all in there, maybe some orange zest, and just kind of leave it. But the real accurate way to do it is you want to infuse those molecules directly into the water, and then you want to taste the water, and when the water tastes like how you want it to taste, you then want to strain it, because if you leave the thyme, you leave the bay leaf in your brine, they'll continue to diffuse their flavor, and it might get stronger than you would like it, so it's going to be a little bit less accurate.
so make your brine, let it sit, let it sort of marinate for a while, and then...
Yeah, I mean, for me, the easiest way to do it is make it like a tea. So if I want rosemary in my brine or something like that, I'll bring some water up to a simmer. I'll throw the rosemary in and let it steep, not boil because it'll become too harsh, and kind of just taste it over the course of a few minutes. And when I have the flavor that I want, I'll remove the rosemary. I'll add the salt and the sugar at that point because it'll dissolve very rapidly, but it'll also dissolve easily at room temperature too. You just gotta whisk it a little bit longer. And then I'll let it cool to at least room temperature, obviously, before I brine my meat with it because I don't want to introduce a hot brine to a raw cold meat product. Okay, John, do you have a question?
Yeah. Would you be able to use a little bit of alcohol to kind of, not emulsify, but draw in the flavor compounds?
You could, and that kind of gets us into our marinade talk, which marinades work exactly like brines in the fact that they diffuse into your protein and they partially dissolve protein fibers. And the three major components for a marination is alcohol, acid, and alkaline. And they all affect differently. So we did that chicken the other day where we sprinkled it with a little bit of sodium bicarbonate, right? And it made it really, really tender, almost velvety, right? And we rinsed it off so we didn't have the sodium bicarbonate flavor. But that was an alkaline marinade. You can also take lemon juice and you can coat your product in lemon juice. You usually want to dilute it with a little bit, so maybe you do like lemon juice and water, lemon juice and reduced red wine or some other flavor. Because what happens is acid, the same reason why it makes it tender, is the same reason why you can have ceviche, which is a fully cooked fish that's never been cooked. You're cooking it in acid. So the acid causes the protein fibers to slowly coagulate. And when they partially coagulate, they're able to retain moisture, and they have a more tender texture. Acid will also break down, connect to tissue, but you run the risk of possibly cooking your meat. Okay? Alcohol works separately as just how the raw alcohol will affect the protein molecules, which again will break them down, degrade them. It'll degrade connective tissue as well. I tend to not like raw alcohol marinades. I think the flavor is too harsh. So when you see me use wine for a marinade, I cook it off and I add it into the bag, and I'm using it just for flavor infusion. So some of the flavor will diffuse inward, but I'm not necessarily using it to tenderize. I'll either tenderize through cooking by applying the appropriate cooking technique or method, maybe tenderize a little bit by adding some salt, so I'm kind of making like a brineade where it's part brine, part marinade, or I'll maybe add, you don't want to add alkaline because wine is already slightly acidic, so you're going to get like a weird fizzy thing going on. But you can also add enzymes, and that's the fourth way to marinade. Papin from papaya, Physin from, actually I'm sorry, I believe papin comes from pineapple. It's in your
It's
papaya, is it? And then there's Physin that comes from, I believe, fresh figs. I have it all listed there. I'm kind of drawing a blank right now. If you look in towards the end. And then there's one more enzyme in pineapple. Yeah. So, and what's interesting, if you ever like, in culinary school once I took some bacon and I wrapped it around pineapple, and I was gonna do like a bacon pineapple little like skewer thing. And I did the day before, and I came back the next day and like almost all the bacon was gone. Right? It was dissolved. So pineapple is a very powerful tenderizer. And you'll see that a lot of times, like in like sweet and sour pork recipes, because there's already pineapple chunks in the recipe, they'll have you juice part of the fresh pineapple. Now, it only happens with fresh. You can't use canned pineapple because the canning process deactivates the enzyme.
bromelain.
Bromelain. Yeah, thank you.
You're welcome.
I'm actually sensitive to fresh pineapple and can't eat it. You can only eat canned pineapple probably for the same enzyme.
Yeah, it's pretty astringent stuff. I mean, if you eat too much pineapple, you kind of like I get that mild irritation as well, where it just, and I think it's just because even though it tastes really sweet, I think there might be, the enzyme could be at play. I don't know factually if that's true, but also just pineapple contains a lot of acid too. That's brines and marinades, so you can apply these to your meat to infuse flavor and to tenderize.
I have a quick question. In your gradient brine formula, would you just stick to that and make the chicken taste good and then complement it by a sauce rather than adding things to your brine?
Yes, that's my personal preference. I find it's easier. As I mature in my cooking, I tend to want to express things in their truest sense for the most part. Every now and then I tend to get a little wacky and have fun with something. But for me, like when I make chicken, like I want it to taste like the truest sense of chicken. If I make pork, I want it to taste like the truest sense of pork. And that's just me. There, again, are always exceptions to the rule. But yeah, to answer your question, I prefer to just do a very simple brine with my chicken, pan roast it perfectly, and then do a nice chicken-based sauce or maybe something else that is going to add a complementary flavor that enhances chicken as my primary ingredient.
And for red meat like venison or buffalo, would you want to brine because there's very little fat, or would you rather add fat some other way or flavor some other way?
It's a good question. So again, brining helps it maintain moisture during the cooking process, and that's more important when you're cooking a very, very lean product to a temperature where the muscle fibers themselves will start to squeeze and extract moisture. So things like venison steaks or chops or like a buffalo tenderloin, I prefer mine rare. So I might marinate to add a little bit of flavor, add a little bit of, and the marination process again kind of works like a brine. It'll help it maintain a little bit of extra moisture. But because I prefer it rare, I'm not really going to be flirting with the temperatures that are going to dry it out. So for me, I just sear it rare and serve it. But if you had someone who was finicky and wanted to eat something lean like an elk chop above, at or above medium temperature, then I would definitely recommend brining it. Okay. Any more questions?
Your formula up there, 5% salt and it's 3% sugar. Right?
And so what that does is, so instead of formulating a bunch of different crazy brines for everything that we brine here, we have like 2 5-gallon jugs of brine, and then we adjust our brine times based upon what we're brining. So we brine our chicken breast for this long, we brine our pork tenderloins for this long, we brine our fish for this long. If we want to add a flavor, which we usually don't, we can take that brine off separately, infuse the flavor, strain it out, and add that. So this makes it a lot more simpler, because then you get used to using one brine. And then you have all these other people who are just like, so you view all these different recipes, right? So you get a brine time that you like, that makes your meat salt, the right seasoning and the right moisture content. But everyone in their cookbooks, they're like, well, this is my brine for chicken, this is my brine for this is my brine for that. And they all have different salt ratios, they all have different times. And this gives you a better understanding of like, no, this is the time that it takes for a 5% brine to penetrate something and make it the way I like it. Yes, sir.
So following your logic that you don't really need to brine things that you're going to cook mostly rare, medium rare, why did we brine the salmon yesterday?
Good question. Do you have the answer?
I do, because it keeps the albumin from leaching out of it.
Yeah, so the structure of fish and seafood in general is much more delicate than any land animal, really. So the muscles, fibers are going to start to constrict at a lower temperature. The collagen, which is very, very little in fish, starts to melt out at like 90 degrees Fahrenheit, if not lower. Some forms will actually melt out at around 70. But the albumin, the fat in the fish, will also melt out at a lower temperature. So the salt helps to partially coagulate that albumin, which is a big part of the moisture content of salmon and most seafood. And so it helps to maintain that moisture. So that's a very good question, though.
So were the scallops, were they brined or marinated?
I'm not sure. Do you guys brine them? No? You could, though. When we run scallops on our menu, we brine them. And the reason why is because it's an insurance policy. Also, too, if you come in and you order like a 4-course tasting menu and you have scallops second course, we're probably going to sear the scallops while your salad's being made. Just give them a quick sear on both sides and put them off to the side. They're almost always cooked to perfection once you sear them on both sides. They don't really need to be finished. But then they're going to drop to room temperature, and that's an execution thing. That's to make sure that when the salad is retrieved from your table and they fire your next course, if we're jumbled for space on the stove, we don't have to wait for that space to clear and then take the time to sear your scallops. So they're already seared, we pop them back in the oven, and then when they're warm, we plate them. With unbrined scallops, you do run the risk of that 2-step process drying them out. So the brine is our insurance policy to make sure that doesn't happen. Okay?